Hello, my name is Karen van Creveld. Since completing my MSc in Light and Lighting more than 20 years ago, I've been a practicing lighting designer undertaking a wide range of architectural projects. I've recently returned to study at the Bartlett as a PhD candidate. My application for the Heap Bursary is to enable me to undertake a specific research project entitled Measuring Real Daylight Exposure Afforded by Various Architectural Environments and the Implications for Our Health and Well-Being. Whilst we evolved as a diurnal species, daylight availability is no longer a defining condition for human activity. We now spend significant time indoors during daytime hours under artificial lighting that's been designed to satisfy our visual needs only. Whilst we have for many years recognized that light may impact humans over and above the visual system, scientific research is now beginning to decipher the physiological and neural mechanisms that lie behind these processes. To date, several advances have been made in identifying the role of light in training our circadian system to the solar day. However, this is but one of several areas where light is acknowledged to impact our non-image forming functioning, and ongoing research is vital to elucidate other regions of impact and what this means for the design of our lit environments. Given the extent of our involuntary and wide-ranging responses to light, it seems imperative that we focus attention on quantifying our current exposure to daylight. In many respects, daylight is considered to be the ideal light source. My proposed research will be valuable in clarifying the extent of any deficiencies with regard to current daylight exposure afforded by different building environments. In doing so, this research will contribute to establishing criteria for the type of daylight ingress needed inside our buildings to meet both our visual and non-image forming needs. The aim of this research is to understand the actual daylight exposure experienced by populations in a wide range of typical working environments found in our current urban context. For most adults, daylight hours are spent in working environments, and therefore it is these settings initially that warrant close examination. A range of working environments with different amounts of daylight access will be considered. These will range from spaces with fully glazed roof structures to environments with limited clear-story windows, and at the extremes, spaces having no daylight at all, to open exterior environments with uninterrupted access to daylight for comparison. As far as this author is aware, no comprehensive review of daylight has yet been undertaken in this manner. My proposed study will address this gap in the research. The study will measure the intensity, spectral composition, duration, timing, and distribution of daylight within the visual field as experienced by the occupant. Measuring devices will be positioned as close as possible to participants' eyes to estimate as closely as possible the light entering the eyes. The objective is to define a scale of daylight exposure potentials afforded by different architectural forms typically found in our working environments. Two separate techniques will be used to measure the light field experienced by the participants: a commercially available wearable light sensor and a calibrated spectrophotometer. The wearable sensor will be worn continuously for the duration of the study. The spectrophotometer will record measurements in a major and minor axis at designated intervals during the day, giving a picture or snapshot of the participants' light experience. A spectrophotometer will be mounted onto a custom-designed mobile frame and will record intensity, which is photopic lux, and the spectral composition of the lit scene being viewed by the participant. I will carry out statistical mapping of the two sets of data to establish whether there is a correlation between the two measuring systems. We know that data from the properly calibrated spectrophotometer will deliver accurate measurements. By comparing these two sets of results, I will be able to determine the accuracy and reliability of the wearable device for future research purposes. If a workable relationship is shown to exist, my research will validate an innovative and cost-effective method of measuring light received in real architectural spaces. This work is crucial to advance a closer collaboration between scientific research and application in real architectural environments. Importantly, the data from this study will be open access, which all SLL members will be able to use for further study in this area.